What is the scalar product or a dot product? There are two vectors A and B, and they are two non-zero vectors inclined at an angle theta. Then scalar product of A vector and B vector is denoted by A vector dot B vector and is defined as the scalar A vector modulus of A vector B vector cos theta. This is how we found the projection of one vector onto this vector. Okay, let us find y in a different perspective. There are two different ways in which we can usefully define the multiplication of two vectors. The first of these is called the scalar or dot product. Let us take a look at the picture below, which gives the definition for two vectors A and B. Also shows a very neat practical application. Take for example the vector A, okay, which is the force or the pulling force given by the person in the picture. Vector B is then given by the distance moved through multiplied by the magnitude of the component of the force in the direction of motion. You remember, this is represented as the work done. The force, the pulling force, constant pulling force is the A vector, and the displacement along the ground, that which moves along the horizontal ground, okay, that is the B vector to a distance B. Okay, so this is what the two vector is about. So we want to find the magnitude of the component of the force in the direction of motion. We are not concerned about the direction of the thing, we are only concerned about the magnitude of the components of the force. That is, what is the resultant force. Okay, this is how it is formed. That is, what is the displacement is formed by modulus of A, that is modulus of B, cos T. T is this angle, the angle in which he is pulling the block. So we define the scalar product as A dot B equal to modulus of A modulus of B cos T, where T is the angle between the thing. To use the least amount of force possible, we would need to pull horizontally so that we are pulling in the same direction. That is, if you need to pull this block, we have to apply the force in this direction horizontally. Okay, that means this angle will reduce down to 0. So he has to pull horizontally. Okay, so if the angle is 0, then the work done equal to A dot B, that is equal to modulus magnitude of A into modulus of B, that is magnitude of B. Force into distance moved, magnitude of the force into distance moved in the direction of the force. Okay, if it is going to be 90 degrees, think that he is going to pull it vertically up this way. Okay, if he is going to pull this block vertically up, there won't be any displacement, that is, the angle would be 90 degrees here. Look at that. Okay, so if it is, there won't be any displacement, work done would be nothing. So the force applied would be vertically above. So there won't be any net effect. Dot product of it is 0. So cos 90 is going to be 0. Hence the product would be 0, and that shows the displacement is going to be 0. This is just to get a picture of why they are using modulus A, modulus B, and how the cosine function is helping to find the scalar value. We will think about the vector value at a later date. Okay.